Greetings to all. Welcome back to the course on Introduction to Electric Vehicles. So in last video, we have learned about the battery management systems and the important terminologies which are being used in the battery management systems. So in this video, we'll be learning a basics about the modeling of the battery. So we have learned that in battery management system, we have to model a battery in terms of some equivalent circuit, which represent the working of a actual battery. So we will be focusing on the ECM method, although there are very different varieties of modeling. So the battery modeling is a method of modeling a battery using some of the electrical components or the electrochemical components. The main purpose of modeling is to actually predict what the battery is going through. So battery modeling uh, of can be done in various ways, like electrochemical model, reduced order electric model, equivalent circuit model. So this is important because this is the simplest method how we can model or how we can mimic how a battery can behave in different situations. And then there is a data driven model. Also there are thermal models like heat generation model, heat transfer model. These are on the side of little thermal side, the thermal modeling of the battery. And then the combination of these two, like coupled lump parameter model or the coupled distribution parameter model. So these are very advanced stages of modeling. So we'll be sticking to the equivalent circuit model, which is simpler and which is mostly used for the BMS systems. At least the simpler BMS system uses this equivalent circuit model. So let's compare between the electrical models. So there are three types of electrical models. We have basically the electrochemical model, EM model, ECM model, number 2, number 1, and number 3. So this reduced order electric model is also a equivalent circuit model only. So there are basically three models which are highly used. So the EM model or the electrochemical model is very accurate because actually what happens, the battery is an electrochemical device. So when we are doing a electrochemical modeling, then it is mostly accurate, or it is more closer to the actual battery. So this explains the full battery composition or full battery reaction. But the problem with this modeling is it is very complex and high computational power is required. One problem which is faced during the implementation of BMS is that you will be using some kind of the microcontroller, and this microcontroller has some limited mathematical capacity. So you cannot put the full power of your mathematical capacity into battery modeling. So you have to divide things. You need a simpler model which takes less mathematical complexities. So this becomes unsuitable for online control task, and which is the most important. The online controlling is the most important. So ECM is the electric circuit model, and this is very simple, and this is widely used for real-time implementations. Another model is DDM, or the data driven model. This is also good, but the problem with this, if you do not have a right data, you will model the battery wrong. So the quality of data becomes very crucial in the data driven model. So ultimately we zero down things to the ECM model. So the lacking information about battery intrinsic feature inferior to model is, so the problem with this ECM model is this is less accurate. But the good thing about it is it is a simple modeling, and it can be used in a real-time system where it takes a less space in the microcontroller or the controller part. So these are the three main used modeling methods, out of which the ECM is used very widely. And today, because the computational power is increasing, people are going with the data driven model or some with the electrochemical model. So what is electric circuit model and how it is being modeled? So in any kind of battery, we have a battery voltage and the battery resistance, which is known as an internal resistance. So internal resistance is a very important part, and it shows how the battery deteriorates. So as the battery is charged and discharged, this cycle goes on, the internal resistance increases, and as the internal resistance increases, the capacity to draw current or capacity to draw power from it reduces. So this circuit is simple circuit, and it is modeled using 1RC method, 2RC method, or 3RC method. So here I have shown the 1RC method, where the battery is, this is the open circuit voltage, this is a R internal, and this R1 C1 are kept in parallel to mimic the how the battery works. because battery has some capacitive effect also, so that has to be included in the circuit. So this is included using the R1 and C1 circuit. So this is known as one RC model because there is a combination of, this is known as RC. So this is known as one RC model. Similarly, if I will be using one more resistance and one more capacitor, so this will known as the 2RC model. So there is one RC model, 2RC model, and 3RC model. So as you increase the RC model, if you compare one RC model with the 3RC model, the accuracy for the 3RC model is better. 3RC is more accurate, but also more complex, because as the number of RC increases, the complexity also increases and the computational power required to model the battery is also increased. So there are 4 parameters: open circuit voltage, which we all know of the battery, then R0 internal resistance, R1 and C1. So depending on this, we can estimate the voltage at any moment using these 3 components: the open circuit voltage, R0, R1, C1. So the first step to be before modeling a battery is we have to measure its resistance, and we have to obtain these 3-4 parameters. And after that, we can model a battery and we can estimate what would be the present SOC of the battery. So at any moment, the controller at every moment estimates what is the SOC of the battery, what is the SOH of the battery using this circuit. So this circuit becomes the prime focus in the battery management system, because if you estimate the charge wrong in the battery, then that will create a problem. So estimating becomes the most crucial part in the battery management system. So this is all about the electric circuit modeling. In the next video, we'll be going to the charging and discharging methods, and also we will learn about that which methods are being popularly used. So thank you for watching this video.